Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, so today we're going to look into what we call chapter 3. As you see on the screen here now, the topic of sequences and series. And this topic will be divided into two parts, which is the first one is sequences and series, and 3.2 binomial expansion. Okay, so we're going to look into the first part, 3.1, sequences and series. Okay, so at the end of this topic, students should be able to find the nth term of arithmetic sequence and use the sum formula we call of this Sn or this one here now and sequences and series. So let's find out why sequence we call sequences and series. So there's what we call a pattern of numbers. As we call, for example, we have 2, 4, 6, 8, and 10. So finite sequence. Finite meaning there is we call the end of the numbers here, 2, 4, 6, 8 until 10. And as we call the finite sequence, and 2 plus 4 plus 6 plus 8 plus 10, then we call it as a finite series, which means that it has the final term, the last term, which is 10 also here and also 10 here. Okay, for this one here now, 1, 3, 5, 7, dot, 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 meaning it is there is no ending of this, and we call the series of this number here. Then we call it as an infinite sequence, and 1 plus 3 plus 5 plus 7 plus dot dot, meaning that if there's a plus many more numbers, there's no end here, then we call it as an infinite series which has no last final term. So find the nth term of the sequence of this. So let's take a look at this one here now. This is the first term. And we got second term, the third term, the fourth term, and the fifth term. Okay. So let's T1 equal to 4. That we can define this as a 3 times 1 plus 1. Okay. In this case, we just imagine that we can form any formula of numbers that one, okay, the numbers, once we substitute the numbers inside this bracket, it will give you exactly, we call the value of the first term as this one here, which is equal to 4. And then T2, 7, which is 3 times 2 plus 1. T3 equal to 10, which is 3 times 3 plus 1. Then also T4 equal to 13, which is 3 times 4. 3 times 4 equal to 12 plus 1 equal to 13. And T5 equal to 3 times 5 plus 1 equal to 16. So then we call the formula, the nth term of this sequence is equal to 3n plus 1. Okay. So now, arithmetic sequence. So when it comes to arithmetic sequence, we call it numbers with a pattern of numbers with the first term of A and has the common difference D. Form of the form of A plus D, A plus 2D, A plus 3D, and continuing. Okay. So then, so when it comes to let's try on this. This one A is just like Okay, this one here, a plus 1 minus 1 d. So 1 minus 1 equal to 0, and this is the first term. Then T2, we get this, T3, a plus 2d, a plus 3 minus 1 equal to 2, 2 minus 1 which is equal to 1, and then 4 minus 1 equal to 3. And we simplify this as the nth term equal to a plus n minus 1 multiplied with d. So the nth term of arithmetic sequence is given by this one here now. Okay, as example number 1 here, the 11th term of arithmetic sequence is 52 and the 19th term is 92. Okay, it mentioned here now it's an arithmetic sequence. So when it says that it's an arithmetic sequence, so this is the nth term of the arithmetic sequence. And 11th term equal to 52 and the 19th term equal to 92. So now 11th term, the n, which is a plus 11 minus 1 d equal to 52, and this one here, a plus 19 minus 1 d equal to 92. Okay, so now a plus 11 minus 1 equal to 10d equal to 52, equation 1. A plus 18d equal to 92, equation 2. Okay, so there are two equations with two variables, which is a and d. A and d, we need to find out what is the value of a, because a is the first term and d is the difference. Okay, d is the difference between n plus 1 minus the n term. Okay, so when we have this here right now, when we have two equations, equation 1, equation 2, and two variables a, d, so let's make this one as an equation 1 minus equation 2. Okay, why did I come up with this equation here now, this idea now? Because we got a and we get a plus 10d equal to 52 and a plus 18d equal to 92. Minus here, okay, so a minus a equal to 0, 10 minus 18, negative 8d, and 52 minus 92 equal to negative 40. So then d equal to negative 40 divided by negative 8 equal to 5. Okay, and then we need to find out what's the value of a here. So substitute d5, d equal to 5 into equation 1. A plus 10 d5 equal to 52. 10 times 5 equal to 50. Bring to the side become negative. So then a equal to 52 minus 50. Then it equal to 2. Okay. So a equal to 2 and d equal to 5. Find the 1000th term. So 1000th term, T1000 equal to a equal to 2 plus 1000 minus 1, d equal to 5. So this is going to give you 999. A equal to just now, which is equal to 2 here. Okay, so 2 plus 999 multiplied with 5. Okay, the total of this, you press the calculator, it gives you 4997. Okay. Sum of finite arithmetic series. So then sum of sum of the pattern of arithmetic sequence here. So the summation of all this given the Sn equal to n over 2 times 2a plus n minus 1d. So the last final term L here. Okay, so for this one here, we consider it as the last final term here. L equal to A plus N minus 1 D. Okay, so this one we can also define as an L. In arithmetic sequence, the 10th term is 3 and the sum of the first 6 term is 76.5. Find the first term common difference. Okay, so mention the equation there, the 10th term, T10 equal to 3, and the sum of the first 6 terms equal to 76.5. Okay, so now the 10th term here is A plus N, 10 minus 1, D equal to 3, A plus 9D equal to 3, equation 1. Okay, and then the 6th term here is 76.5, which is N over 2, 2A plus N minus 1 D equal to 76.5. So N equal, this is N, where N equal to 6, N here. So then 6 over 2, 2A plus 6 minus 1 equal to 5D equal to 76.5. 6 divided by 2 equal to 3. Okay, so 3 here multiplied with 2 equal to 6A. 3 times 5 equal to 15D equal to 76.5. Then this is equation 2. So now, again, we can come up with two equations, equation 1 and equation 2, with two variables of A, D, and also AD. So for this one here now, okay class, for this case, which I think that we can, beside using we call the elimination method, we may also use the substitution method. Let's say from equation 1, let's make this one as an A equal to 3 minus 9D. Bring this 9D to the other side. So 3 minus 9D, then equation 3. Then substitute equation 3 into equation 2. Look at this one here, A. And we got A here. So A substitute, we go replace with 3 minus 9D. 6, 3 minus 9D plus 15D equal to 76.5. 6 times 3 equal to 18. 6 times 9, 54D plus 15D equal to 76.5. So then, negative 54 plus 15, negative 39D equal to 76.5 minus 18, which is 58.5, and D equal to negative 1.5. So substitute D negative 1.5 D negative 1.5 into equation 1, equation 2, or equation 3, any up to you then. So then A equal to 3 minus 9, D negative 1.5, then this one you should get 16.5. Okay. So the next one, the number, the first common difference, the number of terms to be taken so that its sum is 0. So then, Sn, summation of n term that make it equal to 0 then, n over 2, 2a, where a is 16.5, plus n minus 1. Okay, 260 plus n minus 1. And D equal to negative 1.5. And this is equal to 0 then. Okay, so simplify, we can multiply this, 16.5, it be equal to 33. n minus 1. Okay, for this one here now, which is n over 2, 33 plus, okay, negative with this one here, positive. Okay, wait. Okay, minus 3 over 2 n minus 1, then make it equal to 0, and then bring up here now, which is n 66 minus 3n plus 3, make it equal to 0, and you will get n equal to 0 and n equal to 23. By the way, we can't accept the value of n equal to 0 because a 0 term is not exists. So n cannot be equal to 0. So n, we call the only answer here is n equal to 23. Okay, geometric series. Right now we look at the name that we call the next pattern. Geometric sequence is a sequence of numbers in which each term can be obtained from the previous term by multiplying by a constant number called the common ratio. Okay. Let A be the first term and R be the common ratio. So this is the one that we call the pattern here: A times R, A times AR squared, A times R cubed. Okay, so then the first term is A, which is R to the power of 1 minus 1, which is equal to 0. So R power of 0 equal to 1. 1 multiplied with A equal to A. Okay, so we call the formula of the n term for common, we call this geometric sequence is A times R to the power of n minus 1. So the n term and the common ratio equal to R. Okay, this is one here now. So given sequence 3, negative 6, 12, negative 24, and so on. And find the n term and the 9th term if the k term. So now, this is the first term, and this is the second term, third term, and fourth term. So now, as we call the R, the common ratio equal to T2 divided by T1 equal to T3 divided by T2. Okay. So let's take a look at this one here. We have T2 and T1. Let's try with negative 6 divided by 3, which is equal to negative 2. And T1 is also the first term that is equal to 3. So then the n term equal to A times R to the power of n minus 1. Okay, A equal to 3, R equal to negative 2 to the power of n minus 1. And then the 9th term, T9 equal to A equal to 3, R equal to negative 2 to the power of n. Let's say substitute n with 9 here. So 9 minus 1 equal to an 8. And this is going to give you, use a calculator, and it gives you 768. And then if the k term is 192, find the value of k. Now, using this formula, let's say we like to find out if the k term here, okay, the k term tk equal to 192. So AR to the power of k, and is k here now, k minus 1 equal to 192, where A equal to A equal to 3, and then R equal to negative 2, power of k minus 1 equal to 192. Okay. Again, tk equal to a equal to 3, r negative 2 to the power of k minus 1 k minus 1 equal to 192. Okay, so negative 2 power of k minus 1 equal to 192 divided by 3. 192 divided by 3, 6 equal to 18, and then 12, 64 here. Okay, equal to 64. And then for this one, we're going to use the log. Okay, we don't need to use the log then. Okay, so negative 2 power of 6. Okay, negative 2 to the power of 6 equal to 64. So negative 2 to the power of k minus 1 equal to negative 2 to the power of 6. Whereas the base are equal now, so we can just focusing on the index. K minus 1 equal to 6, and then k equal to 7. Okay. So the sum of the geometric series, for the formula of the sum geometric series, a times 1 minus r to the power of n, 1 minus r, or r not equal to 1. So the first term of geometric sequence is 27. The first term, okay, t1 equal to 27. And the common ratio is 4 over 3. Find the sum of the first 5 terms and the least number of terms the sequence can have if the sum exceeds 550. So exceeds in bahasa Melayu called melebihi. Okay. So now the first one then, it mentioned that the first term is 27 and the r equal to 4 over 3. So then summation of the first 5 terms, S5 equal to, okay class, S5 meaning it is we call the summation of the first term, second term, add up with the third term, fourth term, and the fifth term. Okay, it must begin with the first term. The summation of the first n term must begin with the first term here. Okay, so then this is also what we call with the formula of, okay, so Sn equal to a 1 minus r to the power of n divided by 1 minus r. So now this is the value of a and this r here, which is 27 to the power of 27 multiplied with 1 minus 4 over 3 to the power of n, okay, to the power of n here, where n equal to 5, divided by 1 minus r, which is 4 over 3. Okay, so 1 minus and this one will give you, okay class, I think that you may just simply use the calculator because 4 power of 5 is a big number, 3 power of 5 is a big number, 1 minus 4 over 3, just assume that this is 3 over 3. So 3 minus 4 equal to negative 1 over 3. Okay, you may use the calculator. And this, the final answer of this is 781 divided by 3. Okay. Okay, then the least number of term or sequence that can have if the sum exceeds 550. So Sn greater than 550. So it is 27 to the power of 1 minus 4 over 3 to the power of n divided by 1 minus 4 over 3, which is greater than 550. 50. And this one give you negative 1 over 3 multiplied, okay, and then multiply multiply this to the side. It is 27. 1 minus 4 over 3 to the power of n greater than negative 550 divided by 81. Okay. Okay, class. Okay, so we call 27 divided by everything, multiply everything here and divide by negative 1 over 3. So then 1 minus 4 over 3 to the power of n. So simplify between this 27 and negative 1 over 3, and then cross multiply with 550 here. So this one is going to give you, okay, because we multiply with the negative sign here, so the direction change, negative, what we call less than negative 550 divided by 81. And then bring this one to the other side, you still get negative 10, and then negative multiplied with negative, then you come out with 4 over 3 to the power of n. Again, you change the sign of this. Okay, class, just imagine that if I bring this one to the other side, so it becomes negative 81 divided by 81. So negative, we call negative something here, minus something is still negative. So multiply with negative 1 and negative, it change the direction again, become we call greater than. So it is now 631 divided by 81. So now, over 3 to the power of n greater than 631 divided by 81. We change in the log form here. It is n log 4 over 3 greater than log 631 divided by 81. Okay. And then, since that this is greater than 0, okay, we call the value is positive greater than 0, so then we call greater than log 631 divided by 81 divided by log 4 over 3, and use the calculator of this. Okay, for all using of this log, you need to use the calculator. Okay, so n is greater than 7.136. So therefore, the least number of term is 8. Okay, because we are talking about round figure 1, 2, 3, 4, 5, 6, 7. Okay, so the value of n is 7.1 something. So after 7, which is equal to 8. Okay. So find the sum to infinity of the series of this. This again is the first term, this is the second term, and this is the third term. Okay, so term we call find sum to infinity as infinity, which is equal to a divided by 1 minus r. So now, where a or the first term equal to 3 and the r then, which is r equal to t2 divided by t1, then here is 1 divided by 3. So it is a equal to 3 divided by 1 minus 1 over 3, and this is 3 divided by, just imagine that it's a 3 over 3 minus 1 over 3, which is 2 over 3. So bring up here, what we call, it becomes 3 over 2 equal to 9 over 2. Okay, stating a repeated decimal numbers in the simplest fractional form. Okay, express 0.48 bar here. Okay, 0.48 bar here as an infinite geometry series and state as a fraction in the simplest form. So class, in this case, 0.48 bar, which means that is 0.48484848 and so on. There's no ending. Okay, so now just imagine that you have 0.48 plus 0.0048 plus 0.000048 and continuing. Okay, so now class, this is the first term, this is the second term, and this is the third term. So then A equal to 0.48 and R equal to 0.0048 divided by 0.48, which is T2 divided by T1. Okay, so find out the answer. Find out the answer result of this. It gives you 1/100. Okay, so now since that R, which is in between -1 until 1, okay, 1/100, which is 0.0112, okay, 1/100, lies in between -1 until 1, the sum of the infinite series. So then okay, I'll do it here. 0.48 bar equal to A 0.48 divided by 1 minus R, which is 1/100. And this one is going to give you 0. Okay, 0.48 or 48/100 divided by 1 minus 1/100. So just imagine that this is 100 divided by 100 minus 1/100, which is 99/100. Okay, so bring above here, it is 100 divided by 99. So it is 16 divided by 33. Okay, now sorry, class, I do believe that all of you, okay, have been in the, let's recall, sitting in the lecture hall, just like in the universities, or might be here in the Matriculation College. And if you realize that the pattern of the lecture hall will be something like this. Okay, and this is the stage where your lecturer or your teacher stand. So please refer to recall the numbers of recorders seat there. Okay, starting from the numbers might be 10, then come out with 12 seats, and 14 seats, 16 seats, 18 seats, okay, 20 seats, and until the end of the numbers of the seats there. Okay, so okay, this is just an example then. Right now, let's take a look at the question here. A lecture hall has 50 rows of seats with 30 seats in the first row. So 50 seats. The first seat we got 30. In the first row we got 30 seats. Second row we got 32 seats, and 34 in the third seat, and so on until the row of 50. Find the total number of seats. So now T1 also T1 also considered Sn, the first term, which is A equal to 30. And by looking at this, we call pattern of numbers. The difference between T1, T2, and T3 is not by a ratio, but a difference where, let's say, T2 minus T1 equal to 32 minus 30 equal to 2. So T3 minus T2 equal to 34 minus 32, which is also equal to 2. So we are talking about the common difference, which is D equal to 2. Now just imagine that A equal to 30, okay, A equal to 30, so and difference is 2. Just imagine that we list down here, we call the number of seats in the first row, 30. The numbers of seats in the second row, 32. And in the third row, 34, 36, and until the T50. Okay, so what is the total number of the seats? Which means that right now we're gonna use the summation until the 50 term here, S50, which is equal to 50 divided by 2, 2a, where a equal to 30, plus n minus 1, where n equal to 50, 50 minus 1, and d equal to 2. So this is 25, 60, 50 minus 1, 49 times 2 equal to 98. And finalize this, you're going to get, it is 3950. Okay guys, now let's say if two companies offering you a job and the salary or the payment, okay, just like here we call it stated in the statement here now, job 1, this company will pay you $1 million at the end of the month. Wow. Okay, what a big amount, $1 million of USD dollars. Okay, convert to Malaysian ringgit, you're gonna be too rich. So we call this company will pay $1 million at the end of the month. Just recall, work in just 1 month and the company pay you for $1 million, which I think that is more than enough. It's more than enough. Okay, now job 2, this company will pay you 2 cents on the first day. Okay, the first day equal to 0.02, 2 cents. The second day, 4 cents. The third day equal to 8 cents, and so on. Are you willing to work with this kind of amount of payment? I don't think so. Okay, let's move to the recall. Let's find out how much that we earn for that month compared to company 1, job 1 that pay you exact $1 million at the end of the month. Okay, which job will you choose? I'm sure for the first impression, you're gonna choose this one, right? But let's see the secret behind the job 2. Okay, job 1, you get $1 million. Job 2, okay, just imagine this is not $2 but 2 cents. And then 2 squared, which is 4 cents. 2 cubed equal to 8 cents. And so on until you get 2 power of n here. And then, so S30 for 30 days in 1 month equal to 2, and then times 2 power of 30 minus 1. The first term here is 2. A, and then t2 divided by t1, 2 square divided by 2, which is 2 times 2 divided by 2. So it is 2 here now. 2 r equal to 2, r equal to 2 to the power of 30 minus 1 cent. Class, between 1 million and 21 million. But then it looks weird and ridiculous. Am I right? Okay, let's see. How long you need to work for job 2 to earn $1 million? Okay, class. You might think this is funny and ridiculous. You just count or make your own count from day 1 until day 30. This is not something that we create, but this is what we call a great calculation of numbers here. And the total of payment for this one is $21,474,866.46. Okay, but I don't think that if there's any company that willing to pay this kind of amount of money to the workers then. Okay, just imagine it. So find the nth term of the series here. Exercise, so the first term here is A, this is T2, T3, and T4. Find the nth term of the series. Okay, so the nth term, T2 minus T1, 11 minus 5 equal to 6, T3 minus T2, 21 minus 11 equal to 10. So this is not a common difference or common ratio. So for this one, we come up with the first one here equal to 1 square plus 3, or the Tn equal to 2n square plus 3. So this n term that you just, by looking at the pattern of this is not a, this is not a arithmetic or geometric sequence, but it's a pattern of numbers that you need to think on your own. Okay. The n term of sequence is 4n plus 5 divided by 12. Identify that sequence is an arithmetic sequence. Okay. T1, the first term, equal to 4 times 1 plus 5 divided by 12. Okay. Oh no, we're not going to substitute the value inside. Sorry. Okay, for this question, it is Tn equal to 4n plus 5 divided by 12. Tn plus 1 equal to 4n plus 1 plus 5 divided by 12. Okay, so here now, 4 times n, 4n, 4 plus 1 equal, 4 times 1 equal to 4 plus 5 divided by 12. Okay, for this one here now, 4n plus 9 divided by 12. So then, we're going to use that Tn plus 1 minus Tn, which is 4n plus 9 divided by 12 minus 4n plus 5 divided by 12. Okay, so the denominators are equal now. So it's just like 4n minus 4n, clear. 9 minus 5 equal to 4 divided by 12. Or it is 1 over 3. Okay, now, since that Tn plus 1 minus Tn equal to the constant of 1 over 3, therefore, the sequence, okay, this sequence of numbers here is an arithmetic sequence. Okay, find the number of terms between 100 and 500 that are divisible by 7. So class, so the number of x lies in between 100 and 500. Numbers of terms, okay, between 100 and 500 are divisible by 7. So it means that we are talking about the numbers of 101, 102, 103, until 499. By the way, all these numbers is not, not all these numbers that are divisible by 7. So just imagine that if you try by yourself, then you find that the first term is 105. 105 divided by 7, 1 times 7, then the recorded remainder is 3, and then 7 times 5 equal to 35. So 105 divided by 7, you will get exactly equal to 1 we call 15. So 105 is the first term, which is A, okay, and then it is we call 105. Next is 1112. Next is 119 until 497. Okay, this is just a list of numbers that lies in between 100 and 500, but this is the list of numbers that lies in between 100 and 500 that are divisible by 7. Okay, so then D equal to T2 minus T1, which is 112 minus 105 equal to 7. Okay, so then the last final term, the nth term here, equal to 497. Now, so the last final term here, so Tn equal to 497, which is A equal to 105 plus n minus 1 and D equal to 7. So then n minus 1 multiplied with 7, 497 minus 105, 497, 105, 7 minus 5, 2, 9, 392. Then n minus 1 equal to 392 divided by 7. 7 times 5, 35. Therefore, here 7 times 6, 42. 56, and then equal to 57. Okay. So, extra input for all of you. So then a sum of a finite arithmetic series. You see screen here now. So summation of 2Sn here, which I think that you can refer to your lecture notes. All this we call the notes of all this. So this is the one. The sum of geometric series. Okay, so then okay, I can't explain everything here, you just recall. Okay, for this one, the summation of Sn minus R multiplied with summation of Sn. So clear between this AR and AR, this one and this and this. Okay, you can see clear by one. So then, so what's left here now is between A and AR to the power of n. So this is the formula of summation of Sn. Okay, so Okay, so exercise, which I think that I'm not going to answer all the questions because they are exercise number 5, 4, 5, 6, and 7. The rest of it, you may just try yourself. The sum of the first n term of arithmetic series is given by this. The sum of the first n term of this here. Find expression for the n term and the common difference expression of the n term. So now class, let's say Sn equal to T1 plus T2 plus T3 plus until the n. And then Sn minus 1 equal to T1 plus T2 plus T3. Okay, class, I will make some changes there. Okay, let's say plus with Tn minus 1 plus with Tn. And then here, plus with Tn minus 1. So if I make this as an Sn minus Sn minus 1, so then T1 minus T1, T2 minus T2, T3 minus T3, and so on until Tn minus 1 minus this one here. What you get then here now is the n term. Okay. Find the expression for n term. So then this Tn, the n term equal to, okay, this is the sum of the first n term or arithmetic series. So then Sn minus Sn minus 1, which is equal to Sn 2n plus n squared minus Sn minus 1, 2. Let's substitute this n with n minus 1 and plus with n minus 1 squared. Okay, so that 2n plus n squared minus 2n, 2 times n, and then minus 2 plus with n squared plus, okay, no, minus 2n plus 1. So then 2n plus n squared negative, okay, 2n minus 2n equal to 0. Negative 2 plus 1 equal to negative 1. Negative times negative, positive 1. Negative with this one here minus n squared. So n squared minus n squared. So finally it is 2n plus 1. Okay. And then right now we can see here now Tn equal to 2n plus 1. So the common difference here is Tn minus 1, which is 2n plus 1 minus 2n minus 1 here, n minus 1 plus 1. So then 2n plus 1, okay, minus 2 times n, 2n, 2 times negative 1 minus 2 plus 1. So negative 2 plus 1, which is negative 1 here. So then 2n plus 1, negative times 2n minus 2n, negative times negative, positive 1. So 2n minus 2n, so 1 plus 1 equal to 2. So then the sum of 11th term to the 20th term. Okay, so class, for this one, okay, the 11th term, the sum of 11th term, S11, meaning it is T1 plus T2 plus until T11. And then S20 equal to T1 plus T2 plus until the 20th term. So the sum of the 11th term to the 20th term, we make this as an S20 minus S10 because it is included with 11th term here. Okay, class. I read the question we call make wrong interpretation from the question then. Okay, so what the question wants from you for the last statement then. Okay, the sum of the 11th term, meaning that we wanted 11th term plus 12th term, the 30th term until T20. So in this case, we are going to come out with S20 minus S10. The summation of the first 20th term minus the summation that we call of the first 10th term. So which I think that for this one, I wanted all of you to try the question by yourself. For S20, it's just like T1 plus T2 plus until T20 minus T1 plus until T10. Okay, so the formula of summation of the first n term for 20 and Sn equal to 10, you find it yourself and try to solve it. Okay, so exercise number 5, exercise 6. Okay, I'm going to leave to all of you to try the question by yourself and state a fraction of simplest form. And exercise 7. So we call the final answers provided to you. Try yourself. Okay, good luck. And that's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Okay, that's all. Till we meet again in the next series.